Okay, so we're going to be doing another arc length question here. This one will be a little bit messier. Okay, as you can imagine, if you take a function like this, for arc length we will need to find the derivative, and so it's going to get quite a bit more complicated to work with. So remembering our arc length formula, we have integral from a to b, square root 1 plus our derivative squared. So we know a to b, and all we have to do now is find our derivative. So this is f of x, f prime of x. We'll do a little bit of a chain rule. So we have 1/2 x minus x squared to the negative 1/2. So then we do our chain rule. The derivative of x minus x squared will be 1 minus 2x. So we're done with the first part. We go over here to arc sine, and here we have the derivative of arc sine of root x will be this. That's the derivative of the outer function. We plug in our inner function, and again we do another chain rule. We're going to be multiplying here on the side by the derivative of root x, which is 1/2 root x. So this is our derivative. Similar to any of the other arc length problems, the first thing we do is simplify it as much as possible. And for this one, that's going to be quite a bit. So this we rewrite. We have 1 minus 2x. Put this 2 into the denominator, and this with an exponent of negative 1/2 is just going to become the square root of x minus x squared. So that's our first term. Let's go to the second term here. We can rewrite that one as well. Let's put this 2 root x into the denominator with this term, which is going to be just the square root of 1 minus the root of x squared is just going to be x. And so this is what we have. Now you could take this and plug it back in, but this is nowhere near as simplified as we would like. So let's try to bring these two together with a common denominator. And actually that's not nearly as bad as it seems. What we can do with this one to make it look like this second one is we can factor out a root of x. So let's leave the numerator alone. And in the denominator, I can say here we have root x. And if I factor out an x from here, I'm left with a 1. And I'm left with an x. And very nicely, that is actually exactly the same as our denominator for the second term. Now, this is not the only way to have done this question, but it works out very nicely. Now I bring these two together, and I'm going to get 1 minus 2x plus 1. So I'm going to get 2 minus 2x. And in the numerator, which I can factor, I get 2 times 1 minus x. And this is going to be my denominator. Now here I have 1 minus x with square root 1 minus x. I could simplify that even a bit more, and I'll cancel out those 2's. So 1 minus x divided by root 1 minus x is going to leave me in the numerator with the square root of 1 minus x, and in the denominator we have just the square root of x. So believe it or not, this derivative, both those two terms simplify, bring them all together, you are left with just this. And actually that's not even all. If I take that derivative, you'll notice what we want to do is square it, and then we're going to be adding 1. So let's go and do that right now. I know my limits of integration are 0 to pi over 2. And inside we have 1 plus our derivative squared. This part, when I square it, those square roots are going to cancel very nicely. And so what we end up with, this is just going to be 1 minus x divided by x. So again, bring these two together now as a common denominator. And we have 0 to pi over 2. So we have x plus 1 minus x divided by x. Of course, these are going to cancel each other out, and we end up with 0 to pi over 2, and this is just going to be 1 divided by x square rooted, which is actually just going to be 1 over root x, which is x to the negative 1/2. Let's do our antiderivative using the power rule. So we increase that exponent by 1, giving us 1/2. We divide by 1/2, which is the same as multiplying by 2, and that is going to be our antiderivative evaluated from 0 to pi over 2. We get 2 multiplied by the square root of pi over 2 minus 0. This we can simplify a little bit more as well. This is 2 divided by root 2 is just going to be root 2. And so we can put that all together. We have square root of 2 pi, and that is our arc length.